Welcome back to Augustine Chibuzor Mathphysics, and in today's video we continue our question on complex analysis. And today I want us to look at this analytical function. Of course, analytical functions can be seen as regular functions. So in a way, you can be asked if f of z is analytical or if f of z is regular function of z, then prove that the question is to prove. Let me write it down. Maybe we are given something to prove and you have to prove that they are equal. And in our today's class we have some students joining us from Masai Mara University, Narok County, that is the Rift side of Kenya. Of course, we have the host. We also have students from Tangaza University here in Nairobi, and we want to discuss what is this about analytical functions and what is this about regular function. And one of the functions, it has to satisfy Laplace equation and Cauchy-Riemann equation. And I would like our student to give us what we call the Laplacian equations and the Cauchy-Riemann equation. But before they do that, I would first want you to pay a very good attention to today's video, as it's going to help us understand how to prove that this function actually is true. So let's take the. So we want to prove that del squared, the second partial derivative in respect to x, that is dx squared plus del in respect to y, of this modulus function f of z squared. This will give you 4 f prime, that is the derivative of this function, squared. So we are proving that the question says if f of z is an analytical function of z, then prove that the del squared, of course this is a partial derivative in respect to phi. Of course it can be seen as del squared of phi in respect to x plus del squared of phi in respect to y of this function f of z. When you take the modulus sign, will give you 4 prime. This is f prime of z, but you have 4, and this all together will be squared. So I would like Shala joining us from Masai Mara University, Narok County, to give us what is the Cauchy-Riemann equation. What is the Cauchy-Riemann equation? Because that will be the starting point. You must know what Cauchy-Riemann says and what Laplace equation says. So tell us.
Del u in respect to x is equals to del f in respect to y, and del u in respect to y is equals to del phi in respect to x. Of course,
what she is saying is that we have del. This is Cauchy-Riemann. So Cauchy-Riemann says that we have del u in respect to x, and this must be equal to del v in respect to y. And also, according to Cauchy-Riemann, we also have del u in respect to y, and this must be equal to negative del v in respect to x. This is according to Cauchy-Riemann equation. Let me write it in full. It is according to Cauchy-Riemann equation. Okay, so this must be satisfied for us to prove that whatever question that we are given here is true. And let me allow also those joining us from Tangaza University. I have Moffat with us, and I would like Moffat to give us what is Laplace equation according to this formula analytic that we are trying to prove. What is Laplace equation?
It says del u squared in respect to x plus del u squared in respect to y is equal to 0, and del v squared in respect to x plus del v squared in respect to y is equal to 0.
So according to Laplace equation, what we are saying is that the second derivative in respect to x, that is del squared u, in respect to x, that is partial x squared, plus partial u in respect to y, must be equal to 0. And this Laplace also says that del squared of v in respect to x, this is x squared, plus we also have v, this is v in respect to y, and this also must be equal to 0. So this is the Laplace equation, and this is the Cauchy-Riemann equation. So our question must satisfy both the Cauchy-Riemann equation and the Laplace equation. So now we are going to start by trying to find the first and second derivative of these functions, and then prove that indeed they satisfy both Cauchy-Riemann equation and the Laplace equation. I remain your host, Augustine Galagash. Okay, so now let's see what we are trying to say is that if f of z is analytic, it means that it is regular. It can be called analytic or regular. So if f of z is analytic or regular, what this tells you that f of z is equal to u, some function u plus iv. It means that it has the real part and then the imaginary part. So this is what we are going to do. Of course, f of z, when we take the modulus sign f of z in this case, what it means is that you will take the square root of u squared plus v squared. Take the square root of this, and when you take the square root of this, we can square the modulus sign so that you have f of z. When you square this, you will simply get u squared plus v squared, and this will be equals to phi, the function phi that is operating in x and y. So we can say that phi in this case, let's take a different color, phi in this case to be equal to u squared plus v squared. And let's call this our equation number 1. If this is equation 1, we are going to differentiate this in respect to x 2 times, and differentiate this in respect to y 2 times. But for the purpose of this video, it is just as an introduction. So we are going to have part 2 of this video. So if you are joining us, please, after this first series, you need to continue with the second series so that you will find the final answer to this problem, because we might not be able to finish the video, the problem in this video. So I would just make a brief introduction of what we mean by analytic function and regular function, and then we'll conclude in the previous in the next video. So what we are going to do now is differentiating u squared plus v squared in respect to x 2 times, and differentiating u squared plus v squared in respect to y 2 times. And when we partially differentiate this with respect to y, so we need to partially differentiate this with respect to x, and this will be done 2 times because we know it is the second partial derivative. And when we finish differentiating this with respect to x, we are going to differentiate this equation 1. This will be partially differentiate with respect to y, and this also will be done 2 times. And when we are done differentiating both with respect to x and with respect to y, then we are going to check with the Cauchy-Riemann equation and the Laplace equation, and now know if indeed they satisfy both the Cauchy-Riemann and the Laplace equation. You will join us in the next video as we continue with the partial derivative. We are going to be differentiating u squared plus v squared and u squared plus v squared, that is both in respect with x and in respect with y, in our next video. I remain your host, Augustine Galagash.